So hi everyone. The automotive industry was and is still centering around the hardware of vehicles and the corresponding hardware development and lifecycle management. Software is gaining more and more importance in this area in the vehicle development and over the entire vehicle lifetime. But how to create here the software-defined vehicle? So welcome to my talk about the future of automotive is software-defined, how Eclipse Velocitas will help you to create in-vehicle applications. So I'm Andy. I'm working for Bosch Engineering as a software architect for the software-defined vehicle. I'm with Bosch since 25 years, thereof 15 years as a software developer in the embedded area. And since of NT 2016, I'm working in the area of open source in automotive, so I'm a real newbie in the open source world. So, but what is a software-defined vehicle? So the term software-defined vehicle describes here a car containing here some features, some functionalities which are enabled by software, transforming the hardware-based car to a software-centric computing center on wheels. So if you look back, or if you have a look on how it is today, so typically the vehicle is a closed system. Means if you have to update here some software, you have to drive to the garage and to let the people there update your software. But in the future, you will have over-the-air functionalities to increase or to update here your functionalities to become new features and to increase here the customer benefit therefore. With, for example, some security patches, some new infotainment functionalities, or some monitoring functions. And this fundamental shift from a hardware-based to a software-centric wheeled, not everyone would like to hear that, IoT device, requires here also a fundamental rethink to meet here the customer needs. And vehicles of today can already have more than 100 ECUs in the car. A growing array, a growing array of sensors, cameras, radars, lidars, and so on. And you have a lot of software in there, of course, up to 115 million lines of software code. But currently, there's also a trend to integrate and centralize the functionalities in a high-performance central vehicle computer. What is the benefit of a software-defined vehicle? So, for example, you can unlock new safety functions, new comfort, new convenience features. You can buy them maybe via an app store. Let's see what the future will bring therefore. You can receive over-the-air updates like security patches, the infotainment improvements, tuning of some functional capabilities, updates on some operating systems. You have the chance to send and receive here a lot of data from the car to the back end and vice versa. You can pre-process or post-process all this data. And of course, this will also result in new business models. For example, if you can buy then further functionalities like extra power for a track day. So imagine you want to drive on the Hockenheimring or on the Nürburgring and you need here some extra PS. Could be possible, or as Tesla did, some extra range for longer days. What do you need for the software development, or what are your requirements on the software development for the software-defined vehicle? So to build software function, you need here an efficient software development process with short development and short deployment cycles. And often you find here three typical models or three typical options for software development. You can do everything in-house across most or all domains. You can develop here software in-house for some of your special domains, and you can specify here the outsourced development. Or you can completely outsource software development and keep feature specification, integration, and validation in-house. But we would like to create here an open approach for an open technology platform and a community for software-defined vehicle development to accelerate here the innovation of automotive-grade in-car software stacks, cloud-based vehicle operations, and then highly integrated development tool chains. And open source can help here in every domain, in every option. So looking around what's going on out there, you can see here a lot of open source projects. If you participated or attended here in the Automotive Community Day, you see a lot of the examples here. For example, autonomy, the autonomy's future is open source. Then the Autoware Foundation open sourced here some interfaces and tools. Uber, for example, they open sourced AVS and an open source standard for autonomous vehicle visualization. Then maybe you know also Kala, a well-known open source simulator. Then there is Karma. It's from the US Department for Transportation, and they are dealing with vehicle-to-X communication. Then LG open sourced also for the ROS2 for the ROS framework here some simulations, some simulators. Tesla published also some code from their Model S and Model X. Then GM Cruise and Uber open sourced the visualization tool. Continental, also part of the SDV working group, published ECAL, an enhanced communication abstraction layer. Audi also published here some driving data sets, some machine learning libraries, and their so-called functional engineering platform, which they use for their verification and validation processes. As mentioned, traditionally, the automotive industry was and is still centering around the hardware of vehicles. But the software is gaining more and more attraction and attention. And the vehicle and its value is increasingly defined by software. And therefore, we started here with the hopefully future leading ecosystem software-defined vehicle. And therefore, the SDV working group was initiated to mitigate exactly this, to accelerate here the time to market, to share costs, to share risks, change the way of working, and to free up resources to focus on the customer needs. Everyone who attended the last talk about the current state of the SDV working group presented by Daniel, Harald, and Tom, you learned maybe that about 80% of the software typically is non-differentiating, and 20% is the differentiating stuff on which you should focus. And this is also meant here to free up the resources so that you can spend really your effort on the 20% and doing the 80% in the community, for example. By defining here some methods and tools for developing activities for the vehicle applications, to ensure here a high interoperability between the tools and the software, provide an easy access, and establish a base for a reference architecture. And the Eclipse Foundation, with them, we found here a host for doing exactly this work. The working group consists currently, I hope I have the right numbers, because the community is growing and growing rapidly. 24 members in there from different domains, and more members are currently in the queue to join this working group. Let's talk a little bit about Eclipse Velocitas. So here you can see a rough interpretation of a software-defined vehicle, which I have in my mind. So you have here a vehicle with an onboard software stack. You have a connectivity unit with the connection to the cloud, where some services, some managed applications can run. And with a little bit deeper look into the software stack, you see you have here an operating system, you have here communication layer, middleware, software development kit, some vehicle models, programming models, applications, and a vehicle abstraction layer. And to have a little bit an overview where Velocitas is located, it's here visualized. So here you can find the Eclipse project descriptions, in which I want to go a little bit in detail right now. So Velocitas builds here an end-to-end and a scalable and a modular development tool chain for creating here some containerized in-vehicle applications, the so-called vehicle apps. It offers here a comfortable, a fast and efficient development experience to increase the velocity. Therefore, there comes the name, Velocitas, so it's Latin for velocity, for the development team. So in the current times, velocity or the speed is not everything, but it counts a lot. And Velocitas combines here some GitHub Actions templates with Visual Studio Code to an easy-to-use toolchain, realizing here the DevOps lifecycle. The Velocitas software development kit supports in its first contribution Python, and right now also C++, and other languages like Rust will come in the future. In this picture you can also see some other technologies and further working groups, collaboration partners like Covisa to bring that stuff further. So means we do not rely only on Eclipse projects, we use what is out there, what we can use therefore to enhance here this system, this development experience. So Velocitas offers here for each step in the development cycle or in the DevOps cycle a solution. We have here some project templates for a quick project setup using here the GitHub templates, including some workflows and development environment. For coding, we have an app programming model, also able to debug the vehicle apps afterwards and accessing here the vehicle data points and modifying some vehicle functions within the SDK. The vehicle abstraction layer abstracts and makes some model-specific properties and capabilities to a common representation and allows the vehicle apps to be portable. Then we have some GitHub Actions blueprints, which you can directly use. We have some integration tests built in, a deployment and runtime model, and of course, what is necessary, some release mechanisms. And the initial contribution provides here the SDK and the template repositories. And what is also very important, and I came a little bit later to that, is we have here a complete sample application in there that you have a clue how to work with the Velocitas and to have an easy jump start. So let's have a look on the included example for the easy start. At first, you have the request. You want to change, in this case, the seat position of your car. So the vehicle app receives the request, and the app gets then the current vehicle speed, the third step. Then it will trigger here the seat adjustment with the support of the vehicle app software development kit. The service moves the seat to the new position. It returns OK or an error code, of course. And the Adjust the Vehicle app returns then a success message, otherwise an error message. Success or error message will then return to a requester. But see a little bit more here in a short demo. Do you have a little bit sound for me? Okay, but it's just only music, so okay, thanks. Now you see a little bit about the usage of the Velocitas software development kit. Use here some smart annotations. The vehicle model with the vehicle signal specification API. Here's some service endpoints. Publishing the messages to other subscriptions or to other subscribers. Subscribe to the data points. Starting now the runtime environment. Debugging. Testing. Building your first release. Publish your container. Create your documentation. Now it's ready for deployment. I came right now to that. So you can find here how to start. You can find everything in GitHub. You have here the links to the documentation and to the templates itself. So, and now I will come to how to deploy now the vehicle app. And therefore, we have Eclipse Leda. The initial idea behind Eclipse Leda is to have a quick start image on a virtual and a physical device to create here some base integrations for all software-defined vehicle in-vehicle software parts. It's available for all developers and brings all the use cases we want to have together in one place. So a little background on the name and the context of Leda. So Leda was a Spartan queen, admired here by Zeus, and a mother of two half-gods, Pollux and Castor. Just a journey into history. And two other famous women, like Helen of Troy and Clytemnestra. And she has also a star constellation, Cygnus or Swan, created by Zeus. And the main goal behind Leda is to be the birthplace for some great cooperation and integration for the SDV in-vehicle software. So here you can see also the project proposal, or more the project context. And we will provide here with Leda here some system image receipts to deliver here a functional Linux-based image or distribution in the context of the software-defined vehicle, which will be available for really anyone. And the deliverables will be container images, some installable or some flashable image files, and of course the documentation. Find a little bit out here how it works. So you have here the Eclipse projects containing here Cuxaval for the vehicle abstraction layer, Canto for communication purposes, the open container stuff, and Velocitas. Combined here with further open source projects out there like Yocto, like Linux. And this equation comes then to leda. And leda itself is currently running on some Raspberry Pis, so some ARM cores, and on QEMU. So the goal of Eclipse is to provide here exactly the OS distribution, so the framework to have some image files to showcase here some software-defined vehicle use cases. It integrates here the Eclipse SDV and the IoT software components to showcase exactly that, to demonstrate, to use, to interact, to integrate implementations using open protocols and specifications like the vehicle signal specification out of Covisa, Kubernetes, OpenTelemetry, and some further Eclipse IoT related specifications. I have also a small video about leda. Just for the impression that you can see how it will work. Here the well-known included example, the seat service. So here you can find the current documentation, the current project, so the current initial contribution. So we have here some build receipts for QEMU, for the Raspberry Pi, for ARM 64 core, and both or all that stuff as an open embedded meta layer. and of course the documentation. And if you would like to come a little bit closer to that stuff, tomorrow will be the Hacker Day, starting at I guess at 1 p.m. and you will get in contact with all the people from these projects. And to go more into a hackathon, we have in beginning of November, on the 7th November, the BCX in Berlin, and therefore the hackathon with all these projects here mentioned. So if you want to get in touch a little bit more with that, please register to that. So to sum up a little bit, Velocitas provides here a development tool chain for creating in-vehicle applications, the so-called vehicle apps. It increases the velocity for development team. It increases the quality through openness. And of course, it's essential to the success for development activities. Eclipse leda is a kind of an open source, an operating system distribution for a quick start platform with the SDV development, for prototyping your current ideas, and provides here the integration of software-defined vehicle components. So the future of mobility and automotive is software-defined. So let's try to pull all the projects that are out there and relevant for the software-defined vehicle together and build the future vehicle. So you are invited. Here you can find some useful links. Thank you. I'm open for questions now. And not forget to evaluate the session later on. Questions so far? If not, you can also ask during the hacker sessions, the guys and girls, and go a bit deeper into that stuff. You can try it also out. It's available on GitHub. So if you have no questions, thank you for participation, and I guess you will have a longer break right now. So enjoy. Enjoy.